Hello everyone, I am Akshit. Irina, Pratham, and I will be demonstrating the final robotics project of SIT 217 named as PipeBot. Inspection of pipes has never been one of the cleanest or even the safest job out there. Obstacles get stuck inside pipes at random unknown places which are difficult to find. This leads to huge wastage of time and resources. Yet, pipeline workers work in extreme conditions and still fail to inspect the parts of pipeline complicated system because of small diameter of pipes. Sometimes this also puts the inspectors vulnerable to accidents and times when they even have to break the walls to inspect the pipelines. Those times are so much worse and chaotic. Well, our team Tech Phantoms have solved this issue and created a pipe bot that could move and bend inside the pipe with its twists and turns. It simply detects the obstacles inside the pipe and alerts the user using a buzzer whenever PipeBot is on the verge of colliding with some obstacle. Therefore, it displays the distance of the obstacle inside the pipe, which could be easily located by dimensions of pipe. In addition to this, it is a remote controlled pipe bot that works using a smartphone and could travel in all the directions in 2D as it is directed to. For a deeper look to PipeBot, I would hand over the platform to Irina. Over to you, Irina.
So here's the hardware architecture. The components that have been used for the PipeBot include an Arduino Uno R3, which is the microcontroller board and the overall brain, which will run all the necessary scripts and communicate with various sensors and devices. A breadboard has been used for testing the circuit as well as making quick electrical connections between different components. An L298N motor driver has been used to drive two 6-volt DC motors. An HCSR04 ultrasonic sensor has been used to detect the location of obstacle inside a pipeline. A Bluetooth HC05 module has been used for easy communication of the Arduino with the phone application. Two DC gear motors have been used for rotating the wheels in the system. Two wheels have been used for easy movement of the rover. Two 9-volt batteries have been used to supply power to the system. A rotatory wheel has also been used for easy movement of the rover. A 16 by 2 LCD display has been used to output real-time values of the distance of an obstacle. And lastly, a buzzer has been used to alert the pipe inspector whenever the robot comes too near to an obstacle. Now, moving on to the software architecture. So, at first, we include all the libraries which are used to work with the liquid crystal screen, and then we have defined all the const variables for different motor driver control pins. We have also defined the variables for trigger pin and echo pin of the ultrasonic sensor. We have defined a buzzer pin as well, and these are some variables like duration, distance, etc., which are we are going to use later in the program. So these are some lists which are used to design different custom characters to be displayed on the LCD screen. These are just for aesthetic purposes. And the initial display LED is a method which is used to display the initial setup on the LED screen. So first we create the custom characters, display the custom characters on the screen, and then we display the name of the project on the screen. Next is a function which is scroll display, which is used to scroll the entire display on the LED to the left, right, and back to the center. It is just used to create a good screen display, and that's it. So now we have a method obstacle reading, which is used to calculate the distance of an obstacle in centimeter and inch. And then we alert if the distance of the obstacle becomes less than 50 centimeter using a buzzer pin. And then we display the same readings on the LCD as well. So in the setup where the code runs only once, first we configure all the motor driver control pins as output. We set the trigger pin as output as well, the echo pin as input, and the buzzer pin as output as well. Then we give the command for serial communication between the Bluetooth and the phone application. We give some commands for LCD, and then we give the method call to display the initial settings on the LCD and scroll the display. Next, in the loop where the main code runs repeatedly, first we give a condition, which is while the number of characters being read from the serial port are greater than 0, we read the incoming serial data and then we print it. So if the input given through the phone application is to stop, that is S, we configure the voltage of all the pins as low, as you can see here. If the input given is to move forward, that is F, we configure the voltage of forward motor pins as high and backward motor pins as low, that is 0 volt. And if the input given is B, that is to move backward, we configure the voltage of backward motor pins as high and forward motor pins as low, and so on and so forth. We give different inputs and give different commands for different inputs. At the end, we call the obstacle reading function to display the location of obstacle as well as detect if the obstacle is too close to the model. At last, the reference has been given for all the functions used, and handing over to Pratham now.
Hello guys, my name is Pratham Gupta from team PipeBot to explain the design of PipeBot. First we have connect L298 motor driver with Arduino. Second, we have connect Bluetooth module H605 with Arduino so that we can control it wireless. Here is the complete design of a circuit in which we have connected two motors, one battery, one buzzer, one screen, one Bluetooth module, one ultrasonic sensor, and one power supply in case we need it, LiPo battery. Ultrasonic sensor is used for avoiding the obstacles. If there will obstacle, the buzzer will boom and tell us that obstacle is inside the tunnel. And here's the here are two motors attached with our L298 and motor driver module. Here is the screen and here is the Bluetooth module. Next, we have a video of a running project. As you can see, it is moving properly and is avoiding the obstacle. Second demonstration in our pipe. Thank you guys.